Hello everyone. So I'll make a presentation about the creation of a prototype of a wireless system which is meant to be used for a scientific mission in Greenland. This scientific mission is currently running today. They are at the end of the winter. They are jailed in the ice. So first, I will make an overview about my companies and this mission, this scientific mission. The two are independent. I will make a point about the tech challenges in creating such a system. And I will present you the solution. And then I will give you some feedback I received this week from them. So, who am I? I'm Mignien. I'm coming from France. I work for the group ALSATIS, more specifically for this project in ALSATIS Labs in Toulouse. I'm not a trainer, but I and our companies are working with MikroTik products daily since 10 years. So, quickly, the different companies of the group are ALSATIS, which is a wireless ISP in France, operating on Wi-Fi, WiMAX, LTE, and satellite, and also fiber. BlueSurf, which is a sister company from ALSATIS, which do the same, but in the United States, in Maryland. We also have in France, in Toulouse, ALSATIS, which is a company more focused on engineering, training, and consulting for mobile networks. They work for big operators to train their tech operators on 2G, 3G, LTE, and machine-to-machine. And a new company which is ALSATIS Labs, which combine all of the technologies of the different companies and to try to forecast the future and how we will deal with this different new technology in the future. So, for instance, we are working on SDN and NFV, which is a virtualization of the networks, and ALSATIS Labs is a new member of the ONF, an Open Networking Foundation, since a few weeks. So, the UTP2, so UTP stands for Under the Pole. The official website is www.discoverygreenland.com. It's mainly a mission-based, which objectives are exploration, to bring back images, video, and a lot of information of animals and sea creatures. It's also a scientific mission to list species, biodiversities, and so on. They are a team of divers, and they dive to 130 meters depth. They study some relations between atmosphere, ice, ocean, and the human behavior in these extreme conditions, conditions of the North Pole. And this mission has also a goal of testify to report some information about the impact of the current climate changes, and to try to sensitize the new generations. So let's speak about technology, wireless technology. The goal of this project is to create a prototype of a wireless system that allows many applications in an outdoor environment. Let us be more precise. To create a usable prototype of a wireless system that allows many unknown applications in a hostile outdoor environment. So, we will focus on 3 points: usability, applications, and environment. About usability, the mission staff. The mission staff is composed of scientists, biologists. There are neither telecommunication or network engineers. There are no wireless system designers there. So the staff have no knowledge at all about wireless systems, And there are also no pylons or towers, and the electrical power is very scarce there. So the system has to be very easy to be deployed, transportable, no screws and bolts because they are wearing gloves when they are outside, no cables to crimp, easy to point antennas, zero configuration, and system status easy to perceive, to know if the system is running correctly or not, and to have some information about the link presence and to have quality feedback of the link. About the application, I precised previously that the applications are unknown. Why? Because these people are not people who are who work every day with Wi-Fi and similar technologies. They work with VHF, walkie-talkies, Iridium Internet and voice access. So today they have no ideas of how to use Wi-Fi and high bitrate radio cells for their mission. But there are some ideas and opportunities that are emerging, and some of these ideas were identified before the start of the mission in order to create a prototype which could fit these first applications. But the system has to be open as possible to new applications we haven't imagined yet. So, for example, of emerging ideas, the first one is to create a Wi-Fi cell around the base camp. The base camp is a boat which is jailed into ice currently, because we are at the end of the winter. The boat has two big masts, 30 meters high. They are easy to climb, so we can imagine to use the mast as pylons. And this radio cell creation will be good to create communication cell around the boat for PC, tablets, smartphones, rugged ones. Another idea is to create long-distance wireless links, for example, to support some remote and short missions which are distant, to have a local Wi-Fi cell there on the local external mission, which stays connected and linked to the base camp, to also be able to create an autonomous relay site where there is no line of sight between the two sites. Greenland is not only flat ice, the sea is flat when frozen, but there are also mountains and rocks. And there is also an idea to get a better internet access in the base camp from a remote town. During the winter, the boat is jailed into ice, but not too far from a town in case of problem. And there was an idea to let them make a link towards an internet connection from the town and to have this internet connection also in the boat, replacing the Iridium one. Another emerging idea is the transmission of video and telemetry from IP cameras, from Wi-Fi capable drones in summer, and from underwater robots. They have underwater robots, and currently the data is transported over PLC along the powering and controlling cable. And these underwater robots are already IP over Ethernet compatible. And there are many other applications to imagine, but I don't know them yet. About the environment, cold, wind, water, and the sea is salty. It's not good for electric the systems. Darkness, there's no sun in winter, so you can forget solar panels. And yeah, one other tech challenge is the budget. I think, in fact, it's the most difficult technical challenge. But, fortunately, there are solutions. So, why MikroTik? It's a Swiss Army knife. It's cost-effective. Some products are rugged, and it's well known to us. So, which Wi-Fi band to use? We choose to use the 2.4 gigahertz band on 20 megahertz, 11 BGN, to stay compatible with most of the terminals, PC, smartphones, tablets, drones, and whatever. And we are not in an urban area with plenty of noisy Wi-Fi devices, gateways, and so on. So we think 2.4 gigahertz will be good. Which kind of antennas to use? The system must stay usable as much as possible. So we'll try to use integrated as much as possible antennas to create omnidirectional Wi-Fi cells for base camps, and using low or intermediate gain in order to keep an acceptable vertical aperture. Why? Because if you install the omnidirectional antenna on the mast of the boat, it is possible to send the mission far away, climbing on the mountains. So if they are above the level of the mast, the signal will decrease if the vertical aperture of the antenna is too tight. And another type of antenna that is needed is, of course, directional antennas, with also intermediate gain in order to deploy easily, because if the antenna is too big, it will be very difficult to point. Problem with size, wind, and it needs to be transportable also. Solutions about choices, MikroTik products. So for the omnidirectional, we choose a Metal 2 SHPN, which have some interesting specs. It's 2 gigahertz, high power. There is a small 6 dBi omni antenna integrated in the packaging. It's rugged and waterproof. We put an additional antenna, 9 dBi omni antenna, to have a higher gain without electrical tilt. For the same reason I explained before, we want to keep a transmission as horizontal as much horizontal as possible. Other device for directional antenna is the A60G2HND, which is also 2 GHz, high power, a 60-degree sector, MIMO with a 10 dBi antenna integrated, but not rugged nor waterproof. So here are the pros and cons about the two products from our point of view. The pros for the metal SHP, it is rugged, waterproof, low consumptions. It has LEDs and bips. It can be attached using Velcro bands and scratches. The cons, to replace the cable means to cut and crimp a new RG45 connector while wearing gloves. The operating temperatures is announced to be, it has to be more than minus 30 degrees Celsius on the MikroTik official specs. It's SISO, so it's only one antenna. For the A60, the pros are low consumption also. LEDs and bips can be attached the same way. It's MIMO 2x2, 2x2. The cable can be easily replaced, but the cons, it's plastic, not rugged. There are holes and moving parts. It's not waterproof. Yes, fear. So let's have a break. What's the best and efficient method the staff there have found to gently remove the ice of the deck and material every morning? This takes 2 hours every morning. So, answer A, a hot air blower, or answer B, a de-icing fluid. Who is for answer A? Who is for answer B? Okay, you're wrong. Because the correct answer is the baseball bat, yeah. So, fear again. But let's be confident. We will plan some spare, so we need to prepare at least 2 point-to-point links, so we will send nominally 4 A60 units, then we'll send 5. One omnicell, we'll send 2. And we explain the staff not to install the A60s upside down. Let's be confident again. MikroTik staff told me last year when I presented the project that the E60 is rain-proof, serious tests have been conducted, so I'm confident now. Let's speak about configuration. The unit must simultaneously act as Wi-Fi access points for terminals, and we need to create point-to-point links between the nodes. So we choose WDS. So the network must be as much as transparent as possible for the applications because we don't know in advance what will be the applications. So if we use level 3 IP topology, it could prevent some applications like broadcast, multicast, and some non-IP protocols discovery. And using level 3 means having multiple IP subnets to manage. Sometimes it's difficult for some devices where there's no DHCP client and so on to change the device IP during the mission. So we really want a zero configuration solution for the staff. So we choose to use a level 2 topology. So we can do here topologies, L2 topology by two means: natively, attaching an Ethernet interface to a bridge, attaching wireless interface to the same bridge, or making a very complex solution encapsulating Ethernet over IP, VPLS, and so on. But we will keep it simple and use WDS natively to create this level 2 topology. I think you had a presentation this morning about mesh. Level 2 topology implies to implement a loop avoidance mechanism. So there are two solutions. The traditional one, which is STP, RSTP, MSTP, and so on, which elects a route and disables the ports to create a loop-free tree. But in consequence, you will have suboptimal links between sub-leaves of the tree. But MikroTik have a solution which is HWMP+, which is router specific, which is designed to create mesh networks. It elects a new path for each destination MAC address, and it holds the solution in a FDB, forwarding database, and the path selections is based on the interface type and WDS link quality. There is no elected route. Sorry. So we still want a zero config, just something plug and play. We don't want to adjust priorities to force a specific node to become root for the STP. We want optimal path between terminals, so we choose HWMP+ to build the mesh. So here's a sample of the mesh config. First, we create the mesh like we create a bridge. It's very similar. And we set some parameters, like one which is reoptimize path to yes, because the topology is subject to change, because if someone is wearing the node in a backpack and moving around some sites, we need to reorganize potentially the topology dynamically. And one parameter that I like to change is to the automac and to set it to no, and to force the admin MAC to be the one of the Ether1 port. So you have here a sample of syntax to automatically fetch the Ether1 address MAC during this configuration. Then we add the interfaces Ether1 and the wireless one to this mesh, like we do with the bridge. And specifying the port type, there is also a mode to set it to auto port type. I had some problems with that, but so I prefer to force it. And then about the interface, wireless interface, we have to set it in mode AP bridge, like a regular AP. We define the SID, and we define the WDS default bridge to mesh 1, like a bridge. But when we specify the WDS mode, we specify dynamic mesh. We still want zero config, just plug and play. So we need a DHCP server somewhere. We don't know which device will participate to this mesh. So, where will be the DHCP server? We don't know. So, the solution here is to put a DHCP server on every node. So, there is some tweaks about IP and DHCP configuration. We choose to share a big /8 IP range subnet. We put it on the mesh 1 interface. And for each device, where the XX value is a unique ID for each device. So there never be 2 times the same XX value in the network. So every DHCP server will have an IP pool to distribute, which never overlaps the one of the other nodes. And some non-DHCP devices that are statically configured are configured outside these defined pools. Few words about performance optimization. Here we have a scenario where we have 2 areas, the left area, the right area, where at the middle we have a relay built with 2 E60 units installed back-to-back. How to maximize the wireless throughput between the 2 areas? The answer is to make use of 2 radio frequencies to alternate for 2 areas. But we still want 0 config. So we either make some conditional frequency toggle boot up scripts, or either we split the device into groups. So here we have chosen to split the devices in 2 groups to make documentation, to explain the team, and most important part, to put big labels on the units. Still about performances and labels. It's an example. The labels are for the E60 unit S1, S2, S3, S4, S5, and S1, S3, and Si will be in the odd group running on 1 frequency. So if the number is odd or even, you know immediately if it's the same or not frequency. One important thing here is an even wireless mesh area can be connected to a node 1, using an Ethernet cable between 2 units belonging to each frequency. For example, the case of the 2 E60 relay installed back-to-back. Some additional wireless tricks enable encryption. That's something quite classic. To enable adaptive noise immunity, which is possible on Theros chipsets, and compression. And more thing which is very important is on A60, which is 2x2 MIMO, not to forget to enable the chains. So, when I started to make some tests in the labs and collocating 2 metal SHP units, running each one of the channel 1 and channel 12, I got something very weird. I got WDS links established between the 2 units. I think we saw yesterday a very impressive presentation about something weird about radio wireless cards. Somewhat related, I don't know. The consequence is the WDS link is established, but the traffic can't flow through it. And there are some poisoning entries in the HWMP plus FDB, so the system was unstable. So the solution here was to implement areas for the wireless, which is a clean method to separate logically the WDS links. So we implement an area, for example, an area for each frequency. So we have 2 frequencies. To set default authentication on the wireless card to no. Then we'll create in the connect list and access list some entries. On the connect list, we'll add the correct prefix, area prefix, which corresponding to the group, to this interface. So this unit will connect WDS to each unit belonging to the same area. And the last point is to add an empty entry, so here is just add, in the access list just to allow the terminals to connect on the access points. Let's talk now about the visual and audio feedback. So we want to give here some information about wireless link quality, Ethernet port status if possible. S60 and metal SHP have LEDs and buzzer. There are 5 visible signal LEDs on these units. And for the metal SHP, there is also 1 user LED. And the LEDs and the buzzer are usable in scripts, so you can script everything with the LEDs. And the same thing with the buzzer. So for instance, to have the status of the Ethernet interface for the user LED for the metal SHP, you just type this line, and this maps the Ethernet status synchronization to this LED. For the signal, we only want to display the WDS link signals. We don't want to have the signal bar graph to be influenced by the terminals, which are quite locally connected. The most important thing I think is to have a quality information about the long links between the nodes. So we'll take all the ECNR values for only the WDS links. We calculate an average. We map it to a 0 to 5 scale because we have 5 LEDs. And then we display the value on the LED scale. And we also enumerate the value 0 to 5 with bips. So value of 3 bips. So here's a bit of sample code. I don't know if you see well, but I won't go into details. But the first part is variable initialization. Here we get the value of ECNR only for registration entries that are seen as AP. So it's for the WDS links. Then we make a sum. Then we divide by the number of links. So we have consolidated an average. If we have 0 entries, there is a minus 250 value by default. And we map it to a 0 to 5 scale. And then, finally, the 2 blocks, latest block. The first one synchronize this value to the LED scale, and the final one emits the bips. So here we have a script named setLEDs. Then we just have to schedule this script to be launched, for instance, every 20 seconds from the start time to startup. So when the device has booted, every 20 seconds it will update the signal graph with the LEDs and emits bips according to the value. It might be inconvenient to have the bips emitted every 20 seconds, but we are outside, there is a wind, and the main purpose of the mission is not to listen to the bip, but to make some other things, like diving, like studying spaces. So the most important thing, I think, is they are aware about the link status at every moment without watching every time the bar graph. Let's speak about power. As previously said, power is scarce. So the existing power sources there are the batteries embedded in the boat. So there are 24 VDC batteries, which is great to power router board units. And there is also several engine generators, which are launched when needed to generate AC, and to recharge some onboard batteries. But we need some power to take outside to run our mesh nodes. We need an easy to transport solution and easy to use. So last year, at the MUM, I discovered this device, which name is Smart Powerbank from Idea for Tech. I don't know if there are people from them here. No? It's a very compact lithium-ion battery with RG45 ports with PoE injection. Some LEDs to display the status of the battery and the remaining capacities. And on the schema here, you can see how to make the two back-to-back A60s, just plugging two batteries, and at the middle, just have Ethernet cable patch. The problem with lithium-ion batteries, it's not related to this product. It's general for all the lithium-ion batteries. There are pros and cons. The pros, you know them. It's a good capacity related to the volume and the weight. But the cons is the capacity is heavily degraded with temperatures below 0 degrees Celsius. For instance, at minus 10 degrees Celsius, some batteries have a capacity divided by 2. And it's when you go below in the temperatures, the capacity continue to go down. And one of the part is these batteries need to be charged at positive temperatures. So they need to have a very complicated system to heat the batteries and so on to make the charge possible, or to keep the batteries in a warm condition. So to solve this problem, or to mitigate it, we give a lot of units, like giving more spare. And the battery will be charged in the boat, where temperature should stay above 0 degrees Celsius. We give this information to the team. And they will try to protect the batteries during the missions. For instance, you put simply the battery in your inside pocket of your jacket to keep it warm, or in a protective case to make the cold not so important. Quickly about Ethernet cables. The cables must resist to the environment. And like batteries, the problems come from temperature. So not all the UV protected cables today are compatible with such temperatures. If you read the spec sheets, some cables you don't have any temperature on the spec sheets. Some have, but it's only operational temperatures. So you can operate the cable, making a signal and using the cable at these temperatures, but you can't install the cable in these conditions because the cable is very breakable, fragile. And there are some references installable at minus 40 degrees Celsius, but at prices that are very expensive. So here we mitigate using a normal minus 40 degrees Celsius compliant for only operation, and we warn again the staff. About the connectors, industrial connector RG45. That was a huge question, but for this prototype, for the time we had, for the budget we have, that was very complicated to move to industrial connectors. Because this would imply to modify the casing of the A60, to change something on the metal SHP, to permit these new plugs. So despite the risks of breaking the small clip on the RG45 connector, we also warn the staff, and we stay with RG45 connectors for this prototype. Let's speak about packaging and protection. So the solution here was to create a case filled of foam, which has been designed specifically for this project. So there's missing some words. The main goal is to protect a little the batteries for the cold, and to also protect the device during transportation. So I will now show you some pictures of the results. So here you are the case. I don't know if you see it very well, where 10 units Powerbank batteries PoE are inserted in the foam, very tight, to protect them from the cold. Here you have space to embed 2 E60 and also some MikroTik IP cameras. I don't speak about this part, but we also embedded some IP video cameras, MikroTik ones, where you can film all around you with this product, and then record the full video, and then watch it later and zooming which on parts which is interesting. So there are some close-up pictures here. So you can see the 10 smart power banks in the foam, and the 2 E60 and the SHP. Here you are the E60 ready to be packaged with 15-meter cable with the label with the name and the frequency, and the scratch to keep the cable tight, and also to be able to install very easily the E60 on a mast just using this band. On the right side you see the final step of charging of the power banks at the same time before sending the case. Here you have the same with more devices before closing the case. We have the SHP here, and 30 meters of industrial cable ready to be plugged in the cable glands here on the side. And the cable glands are pigtails connected directly to the PoE outputs of the smart power banks. So let's speak now about the first feedback. I have few feedbacks because it's quite new, and I had feedbacks this week. And the good news I received three days ago is they picked up 2 E60s from the batch on the same frequency, of course, and they succeeded to establish a 3-kilometer link between the boat jailed in ice and a small town. So it was plug and play. Great. So here I have pictures, and I will conclude on this. This is a school, and they installed the internet access in this school, so they also shared the internet access for all the children in the school. And the link is pointed towards the boat, and I will conclude with this picture, where we see the boat. Oh, we don't see very well. We see the boat by night, jailed in ice, and the village is 3 kilometers behind. And guess what? What's the green light here? It's the E60. So, thank you very much.